Hey everyone, Johnny and Sean back with you. Hey Sean, how's it going?
Hey, what's going on, everyone? Thanks for joining.
Oh, beautiful, beautiful man. Hey, so we're continuing this series on 3D concrete printing here. Today we're going to go into kind of the design and planning for 3D concrete printing. So we talked initially about really the introduction. Now we're kind of stepping through our series into the design and planning, like I just said here. So we're going to talk today about, kind of an overview of the popular software options. We're not going to drill real deep into it, but just to give folks a sense of that. And then even then maybe some training. We know there's a workforce requirement on some of these things. We're not just swinging a hammer. We'll be using computers, and of course, we're making large scale objects with this, with these machines. But then, of course, what's controlling these machines? How do they get the information to control the shape and the size and all that kind of stuff? So, Sean, what are some of the things you've seen in the field and even in the office and some demos that you've been to?
Well, it's very cool because the complexity of a building is free with 3D printing, and it all comes down to CAD software. You're going to start off with a 3D printing design, just like any type of 3D printer. You've got to tell the machine what to do, where to go, when to stop, and how to actually build layer by layer. And it relies heavily on CAD software. There's multiple projects. I've seen people use SolidWorks, AutoCAD, Rhino, SketchUp. But you want to have somebody on the team who has technical expertise in this field, because if you design it wrong, you're going to print it wrong. So there's a ton of best practices and ways to do it, but definitely somebody who has a super high-end expertise in AutoCAD. And I know, Johnny, with your 3D printing and additive manufacturing background, you have a really good understanding of how to input the data and get out what you want on the other side. Can you tell me a little more about that?
Absolutely, man. So my background, just like you have a variety of backgrounds, Sean, one of the things I used to do was a mechanical design engineer. A lot of people know, of course, in the field of engineering, we use software tools, CAD, so computer aided design what we want. I worked predominantly in components, so something that you could maybe hold in your hand or that you could pick up with a crane or something like that. So we're talking about house shaped or house size shapes here, so larger, but the concepts are the same here. But fundamentally, we're designing these things, which is really the benefit in virtual space before we ever start cutting or printing or machining things like that. We know what we're trying to do, where we're going here. Just like an architect, from a long time ago would design that print, design that house, building, cathedral, whatever it was, and create it and make sure all those components work together before the carpenters and the builders got out there in the field to do what they, to put that thing together. So similar concept here, but this is really interesting in the CAD space, wherein we're not just, rendering in 3D, but we're actually telling the literal, the very specific shape and size of what we're trying to do here. So if the building in a real simple sense is, 10 feet by, 20 feet, and it needs to be 8 feet tall with a certain shape to the walls, we're going to design all that. So we're not going to drill too much into the details of that, but like you said, there is AutoCAD as some popular ones, SolidWorks, and there's just some different companies will use what kind of their preferred software to do that. And then basically there's a processor, and they have a slicing software that processes that data, of course, as we know, and then that puts it into a G code. And then the G code is what tells the machine. I know that sounds technical, folks. We don't want to get lost in there, but we know that type of background. I guess we're going to kind of talk about, there's a software, and then there's the design, and then there's actual input to the machine. Fundamentally, what we're talking about here is we need some training here. Yes, that's kind of the technical pieces that you need to actually create the shape and the size of building that you need from the software. But we need somebody that understands. We don't need someone that writes code, but we do need to have someone with some training that understands kind of how the sequence of events that happens inside the background of what the machine does. And when there is a problem, you can of course modify the code, or so you can modify the CAD model, and it's going to compile it and output that code again. So yes, this is technical, but it's important, and kind of at a high level, we just need someone who understands those basics, and they can run these large machines to create, of course, what we're going for is a home, is a building for someone.
Yeah, and I find that some people or builders who might be looking at this technology might say, hey, I'm old school, I swing a hammer. I don't know anything about computers or code. I write everything down by hand. That's not a problem. There's a lot of the manufacturers out there. What they'll do is they'll take your schematic design and they will import it with their head architect, and they will actually build the code out for you, because there's a lot of advantages using the 3D printing. And a lot of times you might not even be planning ahead about where am I going to be putting, my electrical, my plumbing, do I need any access walls? How are we going to actually do the installation compared to traditionally? So when you can work with a great manufacturer or team, I know some people are out there, breaking the eggs and building their own machines, which is fantastic, pushing the envelope. But I see a lot of new training for skilled workers who have a background in CAD software and using it to implement 3D printing technologies into the slicer to get the G code. So hopefully there's going to be more universities, colleges, and privately funded sponsorships for people to get that education in time.
Yeah, I'll second that, Sean. So the technical schools, even like the trade schools, know this is becoming more prevalent and really kind of the way of the future. So, I mean, even in a lot of the cabinet shops that I'm friends with and other builders, this is getting less and less exotic. Like, oh my God, it's not some kind of like weird thing that you do that only the highly technically inclined can do. They're really making it more accessible to anyone that can, read numbers and just has a basic understanding and high school education, and they can, follow instructions. They're making that much more accessible to a lot more folks. So they're simplifying it, and the training is getting out there. But we need more. We've heard feedback from industry leaders that there isn't the base of knowledge. So they're working on it, but we need a lot more. So that's amazing. So as we wrap this segment up here, Sean, what give us a summary of all that we talked about there as we kind of chatted back and forth.
Well, I think it's the alignment of architects and engineers and people of a CAD software background coming together, because they have to work hand in hand, trying to develop these plans to get the house up and executed in the way that they want. And there's going to be more and more people in this field, and education is key. So keep your eyes out. I'm sure there's going to be multiple manufacturers of these machines who are going to be offering training courses and certifications to get the next generation of builders up into the workforce, which is very exciting.
That's amazing, man. Amazing. So, all right, folks, that's a wrap for this series of the our video series. So it's CAD software and tools for 3D concrete printing. So thank you for just watching and following along on this course. And as we discuss these elements, they're super important. Every one of these things feeds into a successful project, and it just gives the folks a better understanding of what this new burgeoning field looks like. So until next time, Sean, hey, later.
Thanks.